So here we are, 2.6a, college algebra, and this section is called solving linear inequalities. A lot of students hate the inequalities, but really there's not a whole lot of difference between inequalities and equalities. It's the greater than or equal to symbol that we're using. And the key thing is when both sides of an inequality are multiplied by a negative number, we reverse the sign. So that's one of those things that hopefully you remember from a long time ago. So we're going to do some different kinds of inequalities here. So let's start out with the basic simple one here. So again, get your x by itself. So we've got our 5x because we move that over. Minus 5 is less than 6. We add 5 to both sides and we get 11. And we get x equals 11 over 5. Okay, not too bad. 13 minus 7x is greater than or equal to 10x minus 4. Do the same thing. We're going to add this to both sides. Add that to both sides. Divide. And we get x is less than or equal to 1 for our final answer there. Okay, so when we want to graph this, we have a couple different ways of writing this. We've got the interval method, which means if x is less than or equal to 1, that means it goes into negative infinity, and it goes to positive 1, and it has a square around it because it includes 1. It's less than or equal to. So that's the interval notation. If you want it in set notation, x such that x is less than or equal to 1. And if we want to graph it, we have 0, we have 1, and we graph it putting a square box there at 1 and a line that goes into negative infinity. Okay, so now we're going to look at compound inequalities. Compound inequalities basically just mean we have more than one greater than or equal to sign. So when we use the words and or the word or, we get a compound inequality. So if I have negative 3 is less than 2x plus 5 and 2x plus 5 is less than or equal to 7, I have a compound inequality. This one here, when you have the word and, if you remember from your English class, and is a conjunction, and therefore that makes this entire thing a conjunction. Okay, so notice that this number here, the last number and the first number over here are the same. So I can write this as that. Okay, because the signs point the same direction, and I have this this phrase and this phrase that are the same, I can put it in the middle, and I can put that in that. Only when I have an and. If I had an or, you couldn't do that, because we have and is a compound inequality or a conjunction. And when we have the word or, we have something else. We have what's called a disjunction, but we'll get into that in a minute. So when we have this, we're trying to solve for the variable in here, the x. So what we do is we subtract 5 here, subtract 5 here, subtract 5 here. You do it twice. So we get negative 8 less than 2x, which is less than 2, or less than or equal to 2. Now we divide both sides, or all sides, by 2. And we get negative 4 is less than x, which is less than or equal to 1. Okay, so not too bad. The solution set in set notation, set builder notation, x such that negative 4 is less than x, which is less than or equal to 1. So we took our answer to put it there and gives us that. If we want to write it in interval notation, we write that number, and it includes 1 because of the equal sign there. It does not include 4 because there isn't one there, so it's rounded. Okay, and when you graph it, it looks the same way. You've got your -4, you've got your 1, you've got a square there, and a round one there with a line telling you that we're talking about everything in between there. Okay, so that's a conjunction. When we go to a disjunction, that is when we have the word or in there. And when you have the word or, you cannot put them together like I did on that last one. So if we have -2x minus 5 is less than or equal to -7, or 2x minus 5 is greater than 1. We cannot put those together. Okay, for one thing, our signs are not pointing the same way, and the -2x minus 5, or I'm sorry, that should be a 2x, not a negative. Okay. This is not the second term, and this is the first term. So in order for this to work with an and, with a conjunction, this same thing has to be in the first and second here. And if they're both first, it doesn't work. They're ors. So as far as solving them, you solve this one completely separate. And then you do this one. Okay, so we have that answer and that answer. So if you're going to write it in set builder notation, you're going to have x such that x is less than or equal to -1, or x is greater than 3. Okay? If we want to use interval notation, because of the or, we have to use a union symbol. And that means it's a symbol of inclusion, which means we have the first one. X is less than or equal to -1, so it goes -infinity to -1. It includes it, so it gets the box. And then the greater than 3, but it's not equal, positive infinity, and you get that. And the graph then would look like this. Round this way, and square this way. And the square just means that it includes the -1, and the round means it does not include the 3. This is, for the most part, what you're going to be using in these. Alright, so let's do some absolute values with inequalities and see how those go for us. Okay, so let's look at this. If we have the absolute value of x and we say that's less than 3, that means if we have a number line, there's -3, there's +3. Alright, so the absolute value of x, the distance x is from 3, is smaller than 3. So that means that it is going to be, it is going to be a number here, not including -3 or 3. It's going to be a number in here, because all these numbers in here, when you take the absolute value of them, are going to give you a number less than 3. So what does that say? That says that -3 is less than x, which is less than 3. This goes between -3 and 3. If we were to do the same thing with the absolute value of y is greater than or equal to 1, that's saying that y is less than or equal to -1, or y is greater than or equal to 1, doesn't it? Because look at what we have with the number line. 0, 1, 2, 3, 1, 2, 3. We've got -1, +1. What does this say? Y is less than or equal to -1. Okay, so y is less than or equal to -1. It can include any of these numbers. Alright, look what that means. Okay, see, I have y is less than or equal to -1. Because what's it saying? It's saying whatever y is, when we take the absolute value, we're going to get a number bigger than 1. Well, let's try one of these numbers over here. Let's try negative 13, because that fits in here. The absolute value of negative 13, is that greater than 1? Yeah, the absolute value of negative 13 is 13. 13 is greater than 1. It also means that if we have numbers bigger and including 1, those work too. Okay, so let's see what happens. Let's try some numbers over here. Let's try 12. Is the absolute value of 12 greater than or equal to 1? Yes, it is. So do you see how this compound, or this, what did I call them, disjunction works? The or part of the whole thing. Because if this is a number greater than 1, it's got to be all the numbers over here, but we also have to remember that it also includes all the negative numbers from negative 1 into infinity, because when we take the absolute value, we get a positive answer. So, when you have something like this, like an inequality, when it's less than, it's pretty easy. It's like this one up here. It's a conjunction. You just make the signs the same, put the positive and negative of this side here, and you're good to go. When you have the or part of it, when you have a greater than symbol here, okay, so the less thans are easy, the greater thans are a little trickier, because you have to write y is greater than or equal to that, or y is less than or equal to its opposite. That's what I did here. Y is less than or equal to its opposite. Alright, so let's try example 4 and see if we can keep you from getting too terribly confused when we're doing these. Alright, so we have, oops, that's a 2, is less than 5. Okay? Very, very nice for us, because that makes it a conjunction. So we put negative 5 is less than 3x plus 2, which is less than 5. And we just solved this one. Subtract 2, subtract 2, subtract 2. Negative 7 is less than 3x, which is less than 3. And then we divide by 3, divide by 3, divide by 3. Negative 7 thirds is less than x, which is less than 1. So again, in set builder notation, the set of all x such that negative 7 thirds is less than x, which is less than 1. Or in interval notation, negative 7 thirds and 1, both of them rounded, because there is no equal. It's all less than. Okay? All right, let's go ahead and stop this video here, and we will do the B portion of example 4 on the next video.